Okay, so we are now going to try to convert between polar and Cartesian coordinates. And let's see if I can actually stay on the screen. And of course, it's actually fairly simple to think about this if you're simply thinking about points in the plane. You can draw the plane and say, okay, here's my location, and it's maybe -2 in the x direction and +3 in the y direction. And if you said, okay, this is the location r in Cartesian coordinates, r is -2 I hat +3 j hat, and you ask the question, what is r in polar coordinates? Well, that really shouldn't be terribly difficult to figure out, right? If we look at this angle is going to be theta, right? Well, how do you find that angle theta? Well, we pull out trig, right? So you'd say, all right, theta is equal to the arctangent of what? Well, SOHCAHTOA, right? So opposite over adjacent, so y over x, and in this case, is that going to work? We're going to get a negative number for that, so we'll need to make sure that theta actually is a value between pi over 2 and pi. And of course, r, the magnitude, is simply going to be the square root of 4 plus 9, right? Because x squared plus y squared is 2 squared plus 3 squared, -2 squared plus 3 squared, or 4 plus 9. So that's how we'll figure out what that translation is. By the same token, it's fairly easy to go from a polar situation, like let's say you said r was 5 at an angle of pi over 3, right? Well, we could draw that and use our sort of knowledge of trig. So there's pi over 3, not terribly accurately drawn, but something like that. This has a length of 5, and so when you look at this, the sine of pi over 3 times 5 is going to be the y value, and the x value is going to be 5 times the cosine of pi over 3. So the sort of converting from from polar coordinates to Cartesian coordinates is fairly straightforward. It's a little more interesting to start to think about what the unit vectors are and how you translate the unit vectors between the two. In other words, how do you write r hat and how do you write theta hat in terms of I hat and j hat? And think about that. Let's actually just think of an example of where you might be at some point in the xy plane. And so here's what r is, and there's what theta is. And if we think about what the direction of r hat and theta hat is, you remember r hat points in the direction of increasing r, and theta hat points in the direction of increasing theta. Now, one sort of easy way I find to think about this is actually to think about some limiting cases. So let's first think about the case of theta equals 0. Well, in the case that theta equals 0, then pretty clearly r hat is equal to I hat, right? If I'm here, r hat points out along the x-axis, right? And theta hat is equal to j hat, right? What about when theta is equal to pi on 2? Well, r hat in that case is plus j hat, and theta hat, right, because at this point going away from the origin is going in the plus j hat direction, right? And theta hat is equal to minus I hat. Okay. And furthermore, if you actually just start to think about trigonometry a little bit, you can see here that this has a length of 1. So this is actually going to be cos of theta, and this length will be sine of theta, and you can do the same thing for theta hat. So both between the drawing the triangles and doing the trig and just sort of thinking about it from a sort of limiting case perspective, it's not terribly hard to come up with the idea that r hat could be written as the cos of theta times I hat plus the sine of theta times j hat, and similarly theta hat is equal to, well, let's see, in the case that theta is equal to 0, it's got to be a plus j hat, so we've got plus cos theta j hat because cos of 0 is 1. And when theta is equal to pi over 2, it's minus I hat. Well, the sine of pi over 2 is plus 1, so minus sine of theta times I hat. And that is in fact correct. Now I'll leave it for you to think about how do you write I hat and j hat with respect to theta hat and r hat. And of course you have all the information that you need in order to do so right here, right? This is simply a sort of mathematical exercise at this point, and I'm not going to spend time showing you that here.